The final topic we'll discuss in this chapter is how do we do calculations involving uncertainty. So I have here an example calculation. Say we've measured out two masses to figure out how much of a chemical we've weighed out, a solid. So we measured 0.154 grams, and then what was left over was 0.105 grams. So we've dispensed a certain amount, and this solid was put into a volume and diluted up to 0.253 liters. And we'd like to know what is the concentration of the solution in grams per liter. Now, each of these has an uncertainty associated with it. The calculation itself is really straightforward. You just subtract 0.154 and 0.105, take the difference between those two and divide by 0.253, and that'll give us the concentration in grams per liter. Now, the question is, what is the uncertainty in the result? That is what the propagation of uncertainty is the question we're trying to answer. So let's just go ahead and calculate what the final result is. So 0.154 minus 0.105, so that's 0.049 grams divided by 0.253. So we get a concentration that is 0.19, and let's see, we'll do this. This should have like two significant figures. We'll keep some extra ones just in case. 0.1937. We'll keep extra ones and round at the end. 0.1937 grams per liter. And the question is, how do we figure out what's the uncertainty in this final value? Now, there are rules, and these come from the mathematics of uncertainty. We will just look at the final results. We won't look at why these rules exist, but you can learn that from statistics. But there are rules, and these rules about the propagation of uncertainty are ultimately where the rules about significant figure calculations come from. So that's just an interesting thing. So first we'll look at addition and subtraction. We'll come back to this problem. So we'll look at addition and subtraction. There are rules for other operations as well. We'll look at addition and subtraction, multiplication, division, and other rules beyond that we generally won't be using in this class. Okay, so the rule for addition and subtraction is that if we have value 1 plus or minus value 2, that gives us value 3, and each of these has an uncertainty associated with it. We'll call it E1, E2, and E3. The uncertainty is that E3 squared will be equal to E1 squared plus E2 squared. So that's the propagation of uncertainty equation for addition and subtraction. Or we can solve this. The uncertainty in 3 is the square root of E1 squared plus E2 squared. Now, these are all absolute uncertainties. So these are just what is the uncertainty, not expressed relative to the value itself. Okay, so that's the rule for addition and subtraction. For multiplication and division, it's similar, but with a significant difference. So it's still that we're going to square uncertainties and add them together, but if we have, say, value 1 times value 2 equals value 3, and this could be division as well, and each of these has an associated uncertainty, then the uncertainty in 3, and let me change these to A, B, and C, just so we're not getting confused. The uncertainty in C in our result divided by C, that entire thing squared, is equal to the uncertainty in A divided by A squared plus the uncertainty in B divided by B squared. So it's still that we square the uncertainties and add them together, but now you've noticed the difference here is that we're using relative uncertainties instead of absolute uncertainties. We could do this just as easily with percent relative uncertainties, and that's the version that's given in your textbook. So we could write this as the percent uncertainty percent relative uncertainty, in your textbook it writes it this way: percent E of C squared is equal to percent uncertainty of A squared plus percent uncertainty of B squared. Okay, so in the next video we'll look at examples of actually applying these to that problem that I had up earlier.